Good morning, everyone. Today we are here to do our presentation on compilers. We are group number 19, Physical IS. Let me introduce our group members. I am Chatumi and we have Savindi, Pamudu, Deelaka and Kavin. Now let's move on to the topic. What is a compiler? Basically, a compiler is a collection of system programs that transform source code written in a high-level language into machine language. Let me explain this further. High-level programming languages are more like English, and it makes programmers to think in the programming language. Python, C++, Fortran, and Java can take as an examples for high-level languages. But we all know that computer processors can only understand machine language, which is in binary form, ones and zeros. Compiler converts, or we can say translate, this high-level language into machine language. Also, it is used to show errors in the program. Compiler was first invented by Grace Murray Hopper in the early 1940s. Now let's see why these compilers first introduced. Initially, programs for computers were written directly in machine code, which was then updated to being written in assembly language. This was not productive since the programs written in these languages were not portable. In other words, such programs couldn't be reused on different kinds of computers unless they were rewritten in said machine language exclusively for that specific computer. Because of this, the productivity was low for programmers, and programming was limited due to reduced user friendliness. Therefore, the need to have programs in a portable language and its user friendliness was highly demanded, which resulted in shifting towards programming in high-level languages. But computers are restricted to understand machine-level language only. As a result, a translator had to be introduced to convert high-level language into machine-level language and vice versa. This translator was named as compile. From here onwards, to carry out the presentation, I invite to Savindi. Over to you.
Thank you, Chatumi. Let's see what are the benefits we gain from these compilers. Compiler improves performance, it reduces system load and provides protection for source code and programs. Also, it improves productivity and quality. And I must mention the portability of compiled programs. Now, let's talk about the differences between compiler and interpreter. As shown in the slide, considering the programming steps, compiler converts whole high-level language program into machine language at a time, and it also generates an intermediate code. But the interpreter converts whole high-level language program to machine language line by line, and it executes the program without any intermediate code. Then let's consider the running time. In compiler, compilation is slow, but execution is fast. But when we consider interpreter, translation is done fast, but execution is slow. Finally, we will talk about how compiler and interpreter execute the errors. In compiler, errors are displayed after the entire program is compiled. But when we look at interpreter, errors are displayed for each single instruction. Okay, now let's move on to recent advancements made in compilers. In today's world, the trends in hardware technology are developing drastically. Along with this development, More efficient compiler analysis and optimization techniques are needed to generate better target codes for recent machines. Due to this improvement, the world has given its attention mainly to reduce code size and to optimize the execution speed in compilers. The optimization techniques such as reverse inclining, cross-linking optimization, and multiple memory access optimization, etc., are used to reduce the code size. And to optimize the execution speed, the techniques mostly used are loop unrolling and loop vectorization. Now, we reach the end of our presentation. Thank you all for listening.